Good day, everyone. So, before we begin, let us introduce our group. This presentation has been done by our team, and my group member and I will be demonstrating this project. This lab. Myself, Yuaraj, and my group member name is.
Hi, I'm Tharmeindran.
Okay. Today's topic is the program called Add and Subtract, which is placed on add sub.asm, which is currently being shared on the screen. And then also the purpose of the program is it's to demonstrate how 32-bit integer operations are performed using assembly instructions. So okay, we start off with this line, which is include irvine 32.inc. Yeah, that one. It's on line 5. And also the code section will be start on dot code, which is following up from the line 5. Can you show the line dot code? Yeah, okay. And then this main proce, which defines the main procedure where the program execution starts. So let's move on for the step-by-step execution. So for the first step, we have to add on MOVEAX 1000H, 10,000H. We have to use that for hexadecimal value to register EAX. So for the step 2, we have to add EAX 40,000H. So 10,000H hexadecimal plus 40,000 hexadecimal equals to 50,000 hexadecimal. So now the final EAX value is 50,000 hexadecimal. So the step 3 is it's a subtraction. So we subtract 20,000 hexadecimal from the EAX. Okay, so now 50,000 hexadecimal minus 20,000 hexadecimal equals to 30,000 hexadecimal. So now the final EAX value is 30,000 hexadecimal. Okay, now we have to display the output. So we have to add on the call dump regs, which is this function displays all of the register values. So we can clarify the EAX holds, which the final results on 30,000 hexadecimal. Now we have to end the program, which is we have to put the command exit, and then it will terminate the program safely. And then we have to add main endp, and then we have to input that because we have to this is an indicator for the end of the program structure. So now let's move on for the part B, which is just a minute. Okay, which is add and subtraction. So I'm gonna explain that as well. So first let's look at the top of the program. So the title is add and subtract version 2, which is on the first line, and then it also added the add sub2.asm, which is stored under the file. This line simply gives you the program name, and it helps identify the file and what it does. And as same as before, we have to include irvine.inc. This is for the irvine 32 library. And then proceeding that, we have moved to data section, dot data section. Okay, actually, which is include for the wall 1 d word, the 10,000 hexadecimal. The second wall includes 40,000 hexadecimal. The final wall is include the 20,000 hexadecimal. Not final wall, it's wall 3. And then the last one we have changed into our group name, which is section SEC1 group 1 D word. D word means it's a 32-bit variable which is split into 4 bytes. Vol 1, Vol 2, Vol 3 are the initialized hexadecimal values. And then the SEC1 group 1 is actually simply it creates an empty variable that will store the final result data. Now the code section will start. Following up with the line 13, it's have the main procedure, main PROC. Basically, it's entry point for the program, and then we move on to the step 1. MOV EAX, and then vol 1, because this instructions copies of the value from the vol 1 into the EAX register. So now EAX actually have the value, holds the value for the, now the EAX holds the 10,000 hexadecimal value. Now we move on to the step 2, which is we add the vol 2 into EAX, and then so the CPU calculates 10,000 hexadecimal plus 40,000 hexadecimal in equals to 50,000 hexadecimal. So now EAX contains 50,000 hexadecimal. So let's move on to the step 3, which is subtraction. So subtraction SUB EAX vol 3, because so the calculation will become 50,000 hexadecimal minus 20,000 hexadecimal is equals to 30,000 hexadecimal. Now the EAX contains the final result. Okay. Now for the step 4, we have to store result in the memory, so which is it's saved on the line 17. This line saves the result into the variable on SEC1 group 1. Okay, so we move on to the step 5. It's called dump registry. Dump registry, because this is calls the function from the Irvine32 library, which is we have mentioned earlier. So it prints out the current values, allowing us to verify the result. So the final step, not the final step, the exit step is we have to program exit as same as before. We have to input the main end program and then the end main. So this line will end the program and return control back to the Windows. So for the part C, the Tharmeindran will be proceeding.
Hi, I'm Tharmeindran. I'll be covering part C of the lab exercise. We'll be covering add sub 3 assembly code. Its primary job of the code is to demonstrate how we can perform arithmetic on different data sizes, specifically 8 bytes and 16-bit words, and how we store those values into memory. Okay, if you look at the code, I think we have gone through the header. We have the title bit, the title of the code, which is add and subtract version 3, and followed by comments. If you look at here, these 2 lines, there is a syntax error because the first line begins with a semicolon, but the second line doesn't start with a semicolon. I'm just going to show you a quick demo that this will break. So as you can see here, the build has failed as due to some syntax error. So we will correct this quickly. Add a semicolon. What I will do is I'll remove this and I will add a semicolon to indicate this is a new command line. Okay, if you take a look, the build is successful now. So this is a small syntax error that we can correct. Okay, the next part, line 5, is it's stating that we need to include the Irvine 32 libraries so that we are able to do a dump register after all our processing. So it's a helper utility. Then followed by line 6, which is the data section where we define our variable. Think of it as a way for us to reserve space in the RAM. These are, for example, val value W1, value W2, value W3 are all word variable with 1000 hexadecimal, 4000 hexadecimal, and 2000 hexadecimal values. SEC1 group 1 word value is been initialized but without any initial value. Then we have the byte category of variables, which is val b1, val b2, val b3, where they are respectively assigned with 10 hexadecimal, 40 hexadecimal, and 20 hexadecimal. Again, we have a sec1 group B for byte variable with no initial value. We will move to the next part, which is the code section. Under the code section, we have the main proc, which is line 18. Moving to line 19, we have the instruction where we will move the word value into AX register. So AX register would contain word 1 value, which is 10,000. Followed by the next command, which is to add val word 2 into AX register. Followed by the third, to subtract val word 3, which is 2000 from AX register. We will then move the value of AX register into the memory, which is the sec1 group 1 word. We will be calling the dump register to display the output at line 23. Now we will proceed with processing of the byte variable. So we'll assign variable value 1b to AH register, then followed by addition of val b2 to AH register, and then we will subtract val b3 from AH register. Then we will assign the value of AH register into the variable byte variable, which is sec1 group 1b, and we will call the dump register to display the value in the register. So I will just do a quick demo for that. Debug, step over. Okay, so step 1, I think I need to do one more thing. 1 second, I'll just add this. Add watch, add watch, add watch, Add watch. Add watch. Add watch. Okay, so I think I don't have LP. LD, okay. Watch. Okay, next. So, okay, we have process instruction 19. So AX register has been set. 1000H. Next step. It's been added with 40,000. So you can see it's 5,000. I think these numbers are wrong. Minus become 2,000. Finally, sec group value has been set, which is here in the memory. Sorry. Okay. Okay. Not getting that. Proceed. Well, word, well, D1, 16. $4,000. In top registry. And a program ended. Okay, thank you, everyone.